Hi, welcome to Provoke Your Physics channel. இன்னைக்கு நம்ம காஸ் லாவோட அப்ளிகேஷன் பார்ப்போம். அதாவது மூணு அப்ளிகேஷன் சொல்லுவாங்க. ஒன்று எலக்ட்ரிக் ஃபீல்ட் டியூ டு இன்ஃபைனைட் லாங் ஸ்ட்ரெயிட் ஒயர். செகண்ட் இன்ஃபைனைட் சார்ஜ்டு பிளேன் ஷீட்டு. அந்த தேர்டு ஒன் இஸ் சார்ஜ்டு ஸ்பியர். இந்த மூணு டிஃபரண்ட் ஜாமெட்ரிக்கல் எலமெண்ட்ஸோட எலக்ட்ரிக் ஃபீல்டு எப்படி கண்டுபிடிக்கிறது பை யூசிங் காஸ் லா. இப்போ எலக்ட்ரிக் ஃபீல்ட் டியூ டு an infinite charged straight wire அதோட எலக்ட்ரிக் ஃபீல்ட் எப்படி கண்டுபிடிக்கிறதுன்னு பார்ப்போம். See, consider it is an infinite long straight charged wire. For my convenience, I am considering it is consist of positive charge. Okay, so from the point from here to here, I am just going to measure its electric field. Okay, ஏன் infinite wire சொல்றோம் அப்படின்னா, when I am taking any one point, okay, the angle will be nearly 90 degree. Okay, அந்த ஒரு காரணத்துக்காக தான் நம்ம infinite long straight wireன்றது நம்ம எடுத்துக்கிறோம். Here I am going to use the strategy that the charge density அப்படிங்கிற கான்செப்ட். What is charge density? That is linear charge density lambda is equal to Q divided by L அப்படின்னு சொல்லுவாங்க. That means okay, amount of charge flowing per unit length or given length அப்படி கூட வச்சுக்குவோம். Okay, அப்போ Q is equal to, we can simply write lambda times L அப்படின்னு சொல்லி நம்ம எழுதிடலாம். Lambda times L, right? Around this, actually Gauss law என்ன சொல்லுது? Over a closed surface, the electric flux will be equal to 1 by epsilon naught times the net charge enclosed அப்படிங்கிறது தான் சொல்லுது. சரிங்களா? Okay, இப்போ இங்க for this infinite long straight wire, I am considering a Gaussian surface of a cylinder having a radius R and the length L அப்படின்னு சொல்லி நான் வச்சுக்க போறேன். Okay, so if I consider a cylinder, okay, having a radius R, okay, having a length L அப்படின்னு சொல்லி வச்சுக்குவோம். Okay, so here I can choose three different parts, three different position. Okay, one is the cylindrical part. This is a cylindrical part, and this is a top cap, and this is a bottom cap. Okay, so let us choose three different parts. One is cylindrical part, another one is top part, another one is bottom part. So total three. So the net electric flux pi E will be equal to the sum of, okay, phi of top plus phi of cylinder plus phi of bottom. Okay, right. First let us take the Gauss law, that is phi E is equal to closed integral of E ds cos theta. Okay, so I have to find the theta value. See, look at this one here. This will be the ds vector. Okay, and here E will be the direction of this. Now, in the cylindrical part, what is the angle between E and ds? Good, that is 0 degree. Now here, this will be the ds part, and this will be the E vector. Similarly here, okay, so this will be the ds part, and this will be the E vector. Okay, so from this I can easily understand at the top and the bottom part. Okay, so the electric field vector and ds vector have an angle 90 degree. Of course, cos 90 is 0, so there won't be any electric flux over here and here. Okay, so for top and bottom, okay, theta is equal to 90 degree. That is E vector is perpendicular to ds vector. Therefore, in these two parts, okay, phi E will be equal to 0 at top and bottom. Okay, so at the top and bottom the electric flux will be 0, so only the remaining part is the cylinder. At the cylinder, okay, at cylinder, Okay, phi e will be equal to closed integral of e dot ds cos theta. Okay, so here ds and e will be an angle 0 degree. Okay, so theta is equal to 0 degree, that is cos 0 is equal to 1. Therefore, phi e is equal to closed integral of e ds. So of course, let us take e will be outside e, okay, into closed integral of ds. So if I take ds, the value of ds will be, that is the area of a cylinder. Area of a cylinder is circumference times the length. That is 2 pi rl. Okay, simply I just write E into 2 pi r into L. What is this? This is phi E. Am I clear? Yeah. See, so phi E is equal to E into 2 pi r into L. But phi E, according to Gauss law, Q by epsilon naught. But what is Q? So we know that Q is equal to lambda times L. Therefore, lambda times L by epsilon naught is equal to E into 2 pi r into L. I can cancel L on both sides. Okay. So the remaining part I have, E will be equal to lambda divided by, okay, 2 pi epsilon naught r, okay, will be the value of the electric field for an infinite long straight wire carrying charge plus Q. Okay, I hope you understand. If you like this video, please like, share and subscribe. Thank you.